Welcome back. Let's talk about data lakes, right? So storing business content has always been a point of contention and often frustration within businesses of all types, right? Should contents be stored in folders, right? Should you use prefixes and suffixes to identify file versions, right? Or should content be divided by department or specialty, right? So the list goes on and on. The issue stems from the fact that many companies start to implement document or file management systems within the best of intentions, but don't have the foresight or the infrastructure to maintain the initial data organization. So out of the dire need for organizing the ever-increasing volume of data, right, data lakes were born. So a data lake is a centralized repository that allows you to store structured, semi-structured, and unstructured data at any scale. So now let's talk about how data is organized in S3 before I get to data lakes, right? So S3 is an object container, and I've talked about this previously as well, okay? You can put content in an orderly fashion, or you can just dump your data in S3. But no matter how data gets there, once it's in S3, you need a way to organize it in a meaningful way so you can find it when you need it. So this is where data lakes come in, okay? So a data lake is an architectural concept that helps you manage multiple data types from multiple sources, both structured and unstructured, through a single set of tools. So let's break that down so that it's easier. A data lake takes Amazon S3 bucket and organizes them by categorizing them by data inside the bucket. So it doesn't matter how the data got there or what kind it is, right? You can store both structured and unstructured data effectively in an Amazon S3 data lake. Now, AWS offers a set of tools to manage the entire data lake without treating each bucket as a separate, unassociated object. So many businesses end up grouping data together into numerous storage locations, right, called silos. Now, these silos are rarely managed and maintained by the same team, which can be problematic. Now, inconsistencies in a way data was written, collected, aggregated, or filtered can cause problems when it is compared or combined for processing from all these different silos. For example, one team may use the address field to store both the street number and street name, while the other team might use separate fields for street name or street numbers. Now, when these data sets are combined, now there is now an inconsistency the way the address is stored, and it will make analysis very, very difficult, right? But by using data lake, you can break down data silos and bring data into a single central repository that is managed by a single team. Now that gives you a single consistent source of truth. Because data can be stored in a raw format, you don't need to convert it or aggregate it or filter it before you store it. Now instead, you can leave the pre-processing to the system that processes it rather than the system that stores it. So in other words, you don't have to transform the data to make it usable. You keep the data in its original form, however it got there, however it was written, right? Now when you're talking exabytes of data, you can't really afford to pre-process the data in every conceivable way that may need to be presented in a useful state. So let's talk about having a single source of truth, right? So when we talk about truth in relation to data, you need the trustworthiness of data. Is it what it should be, for example? Has it been altered, right? Can you actually validate the chain of custody? Now, when creating a single source of truth, you're creating a data set, right? In this case, the data lake itself, right? Which can be used for all processing and analytics. Now, the bonus is that, it needs to be consistent and reliable, right? It's trustworthy. So, to bring it all together, we know that businesses need to easily access and analyze data in a variety of ways, using the tools and frameworks of their choice. Now remember, the second principle that I talked about in previous lectures, right? Moving data between storage and processing is really costly. Now Amazon S3 Data Lake provides a single storage backbone for the entire solution that meets all these requirements and tools for analyzing data without any additional tools. Now data lakes promise the ability to store all data in a business, right, in a single repository. You can leverage data lakes to store large volumes of data instead of persisting the data into a data warehouse or warehouse. Now, data lakes such as those built in Amazon S3, for example, are generally less expensive and specialized than big data storage solutions. So that way you only pay for the specialized solution when using and processing and analyzing data, and not for long-term storage. Now, your extract, transforms, load, ETL or analytic process can still access this data for analytics. Let's talk about some of the benefits, right? So you understand why companies should implement data lakes or create this architecture. So the first benefit of AWS data lakes, right, are that it's cost-effective storage solution. Now you can durably store nearly unlimited amount of data using Amazon S3, right? You can implement leading security measures and compliance, right? AWS uses stringent security, by the way, okay, and compliance and privacy and protection mechanisms on S3 bucket, which allows you to take advantage of many different data collection and ingestion tools to ingest data into your data lake. Now, these services include Amazon Kinesis, for example, for streaming data, and AWS Snowball, right, for large volumes of on-premise data. So it helps you to categorize and manage your data simply and efficiently. Now, use AWS Glue, for example, to understand data within the AWS data lake, prepare it, and load it reliably into data stores. Now, once AWS Glue catalogs your data, it is immediately searchable, can be queried, for example, and is available for ETL processes. Now, it also helps you turn data into meaningful insights. You can use, for example, analytic services like a wide ways of use cases such as interactive analysis, data processing using Apache Spark, for example, or Apache Hadoop, data warehousing, real-time analytics, right? Operation analytics, dashboards, visualization, you name it. For example, Amazon EMR and data lakes, right? So businesses have realized that the power of data lakes is absolutely crucial, right? So data within a data lake, you can actually distribute the source and use frameworks such as those supported by Amazon EMR, for example. Now, Apache Hadoop, on the other hand, and Spark are both supported by Amazon EMR as well, which helps the ability to help businesses and cost-effectively implement data processing solutions, right, based on Amazon S3 data lakes. Now, the data lake preparation is basically, think about this, data scientists spend 60% of time cleaning data, right? And that's a lot of time. Now, data preparation is a huge undertaking. Now, there are no easy answers, right, when it comes to cleaning data or transforming data and collecting data for your data lake. But there are services that can automate many of these time-consuming processes. Now, setting up and managing data lakes today, for example, can involve a lot of manual and complicated and time-consuming tasks. Now, this work includes loading the data, monitoring the data flows, right, setting up partitions for the data itself, and then, of course, encryption. Now, you may also need to reorganize data to duplicate it, right? For example, match link records and audit data over time. Now, AWS Lake Formation makes it easier to ingest, clean, catalog, transform, and secure your data and make it available for analysis and, of course, machine learning as well. Now, Lake Formation gives you a central console where you can discover data sources, set up transformation jobs to move data to an Amazon S3 data lake, or remove duplicates and match records. Catalog data, for example, so that analytic tools can access it, right? And security policies can also be implemented. You can audit, you can control access from AWS analytic and machine learning services. Now, Lake Formation automatically configures underlying AWS services to ensure compliance within your defined policies. Now, if you have set up transformation jobs, for example, right, using AWS services, Lake Formation can figure out the flows, centralize their orchestration, and then lets you monitor the processing of all the jobs. So I hope this helps you understand the concept of data lake, right? And creating an efficient data lake architecture is crucial when you're designing the data analysis solution. Let me know if you have any questions with this. Let's move to the next lesson.